In a previous video, I explained how phase detection autofocus works in both SLR and mirrorless cameras, and how they differ. And in the Z9 autofocus video, I showed that phase detection autofocus is not open loop. I also covered some of the history behind autofocus and the different modes of autofocus. I'll put a link to those videos in the description. In this video, I'm going to show that phase detection autofocus is also not open loop in DSLRs, and it has not been open loop at least since the early 2000s when I first tested it with the D200 and D300 series cameras. Now, the AF sensor in an SLR has lines of photodiodes broken into functional groups which make up the focus points. Here we have, for instance, the C6 focus point. We have a horizontal line, left and right, which is sensing vertical details, and we have a vertical line, top and bottom, which are sensing horizontal details, and they're sensing the position or phase of the detail along the line. In a mirrorless camera, we would generally call the lines of photodiodes used for focus pixels, although they may or may not actually be used for image recording. Now, the phase offset, or how far off position these two images are, determines how far out of focus the image is determined to be. But that does not equate to a certain amount of focus travel for a few reasons. The first being that the distance a lens has to travel is less when the subject is far, and it is more when the subject is near. So the distance between 3 and 4 feet in terms of focus travel is greater than the distance between 10 and 20 feet, and that's greater than the distance between 20 foot and infinity. The second reason is that the manufacturers use a wide variety of focus motors, which all have different drive mechanisms and with different gear ratios. These are several of the options from Canon's focus motors. There's the ring drive, the micro drive, micro 2 drive, the STM stepper motors, and there's voice coil motors and dual drive motors, which use 2 stepper motors or 2 focus motors in one lens. And all the manufacturers have a wide array that they use, and each one is different. And for anything to move, meaning a focus mechanism, there must be some play in the system. And that means that for any given focus drive position does not necessarily equate to an exact focus image position, or the lens position is not exact. And different drive motors are going to have different degrees of accuracy in that amount of play they have in the drive system. So being open loop and just driving the lens to a certain focus position based on the drive mechanism is very complicated and very prone to large errors. Next, I'll demonstrate closed loop autofocus in the D850. That's the only SLR camera I have available currently, but you can easily duplicate this test with any camera and a slower focusing lens. I have also recorded the focus motor noise of the lens so you can correlate focus drive with the focus indicator and image clarity. Unfortunately, there is a good bit of background noise to the recording, but it is clear enough for you to make out. The test involves starting with the lens in focus, then placing the focus at another distance and out of focus. I then activate the focus and simultaneously reposition the focus point while the focus motor is driving the lens. If autofocus is open loop, then the focus should end at the distance at which autofocus was activated, but instead the focus ends at the point and distance where the focus ends up. The camera is quite clearly using the focus detector to confirm focus and operating in a closed loop manner. That is why you have to disable autofocus confirmation if you want the camera to focus and operate in more of an open loop manner.